Okay, homework 4-6. This problem, these types of problems should not give you any trouble, I hope. They're pretty straightforward, so don't overthink them. You just have, in this case, you have a wheel with 6 slices, and it says, what is the probability that the wheel stops on a white slice? So you got 4 white slices out of the 6. You got a 4 out of 6 chance of landing on a white slice. Next question, what's the probability the wheel stops on a white slice given that the wheel stops on a number less than 5? Okay, so given that it lands either on this one, this one, this one, this one, or this one, okay? So we're throwing this one out of the mix. There's only 5 things it could land on. What is the probability it lands on a white slice? 1, 2, 3 of those are white. Okay, so you got a 3 out of 5 chance given that the wheel, ooh, sorry, start over, I messed up. Anybody catch me? It says a number less than 5, so we got to get rid of 5 too. All right, so I get rid of those two, 5 and 6, because the numbers less than 5 are 1, 2, 3, and 4. Now I've only got 4 things to choose from, and a white slice, 2 of those are white, so I got a 2 out of 4 chance of landing on white, given that the wheel stops on a number less than 5. All right, next. It says events A and B are mutually exclusive. Okay, so when I work a problem like this is what I do. There's event A, and there's event B. If they're mutually exclusive, that's what they're going to look like. Event A occurs with that much probability. Event B occurs with this much probability. Let's answer these questions. Compute the probability that B occurs or A does not occur. Okay, so let's think. Now notice these things don't add, this and this don't add up to 1 because they're in an event space here. So some things may not be in A or B. So there's an event space here that I just drew that has a probability of 1. So when that says compute the probability that B occurs, okay, let's just shade B occurring. If I'm going to show B occurs, that means all of this is shaded in. That's B occurring. Or A does not occur. All right, so I'm going to show you what A does not occur looks like. This is A not occurring. All right, so I need to know, well, what's the probability, or what's the probability of the area, or what's the probability that of the stuff that I've just shaded, okay? So the way you want to think about this is this whole event space has a probability that's equal to 1, okay? This much of it right here we know is 0.76. So 1 minus 0.76 is everything else. So it's all of this is what the part we have is shaded right here, everything but A. Even though this B stuff got covered twice, that's okay. We're just looking, everything but A is 0.24. So I'm going to go with 0.24 here for that one. Then I'm going to draw this again. So here's A, here's B, here's my event space. And now let's answer this question. Compute the probability that either B occurs without A occurring. Okay, well think about that. If B occurs, if this is happening, since they're mutually exclusive, there's no way for me to be over here with anything happening with A. So B is going to occur without A occurring. Okay, so that's B occurring, or A and B both occur. Or A and B both occur. Well, A and B can't occur at the same time. There is no overlap for A and B. So this right here has a probability of 0. That can't happen. So really all I got here is that B occurs. Of course, A is not going to happen when that happens. So the answer to that one is just that 0.1. So I'll take my answer to here. It's equal to 0.1. Usually on these, to me, this first question is a little bit more straightforward. This second question can get a little confusing, but after you work enough of them, hopefully you'll figure that one out. But if you need more help with that, let me know. All right, last one. It says A and B are independent. So here's what you should be thinking of when you're thinking of A and B being independent. There's A, there's B. There is some overlap, and you should know how to find this intersection. This is just going to be the probability of A times the probability of B. Since these are independent, that's how you find that space right there. All right. So it says probability of A is 0.67. Probability of B is 0.03. So we can do a little math real quick. 0.67 times 0.03. So this area right here is 0.0201. Because I just multiplied those together. Get rid of that. Okay, so let's answer this question. And so again, I'm still in an event space. This event space is going to have a probability of 1. Something's going to occur. But notice A and B don't add up to 1 because there's stuff that's going on outside of A and B. All right, it says compute the probability that A occurs, but B does not occur. Okay, so the probability that A occurs and B does not occur. So if we think about that from a visual standpoint, here's A occurring without B occurring. Okay, because if I come in here and start shading this part in, then I'm into B as well. Okay, so I really only want this part out here. All of this is what I want. Okay, so I think about that. What is that? Well, the whole circle A is 0.67, and I don't want to include this part of it, this 0.0201. So I would subtract that away from the 0.67 to get my answer. So 0.67 minus 0.0201, and that leaves me 0.6499 for my answer to this one. All right. Let's see about the second part here. Compute the probability that either A occurs without B occurring, or A and B both occur. Okay, so in the first part we found out A occurs without B is what I've got shaded here in red. So all of this is A. This right here is A without B occurring. And then this part here, A and B both occurring, well, that's the intersection of A and B. That's this part right here. So if I take that red and blue section, add them together, I just got A, which is 0.67. So my answer to this one would be 0.67. Okay, so it's just getting used to some of that wording. But it definitely helps me to draw a picture with those. If you read the Alex explanation, they're going to give you some formulas, and maybe that's easier for you. But I'm more of a visual learner, so I tend to use a diagram, a Venn diagram, to help me with these probabilities. All right, let me know if I can help you.